Welcome back to Operations Management. We're going to start talking today about decision-making. Decision-making is an act of selecting a preferred course of action among alternatives. What is it that you want to do? It can be something as simple as picking out where to go eat lunch, eat dinner. It can be looking at decisions for businesses, location decisions, how much should you charge for a product? All of these are part of decision making. And depending on who your author is, you'll find that there's a number of steps or phases in decision making. This author lists them as starting with a recognition of need for decision. You have to know you need to make a decision in order to make one. Next, you identify your objectives. What are your objectives? What is it that you want to accomplish? What is this decision about? What is it that you need? Then you want to search for reasonable alternatives. When you do brainstorming, you're going to start looking at alternatives, period. And then you're going to weed out which ones are reasonable or not. I've always wanted to try poi. I want to go to Hawaii. I want to have lunch in Hawaii. Let's see. Right now, when I'm taping this, it's about 10:30 in the morning. I have a meeting at 1 o'clock for lunch or after lunch. I don't think I'm going to be able to videotape now, travel to Hawaii, try poi. I want to do the whole luau, by the way, and then get back here in time for my 1 o'clock meeting. So my alternatives that I need to look at have to be more reasonable. So I'm on the main campus. What are some of the alternatives that I might have? I can take a look at restaurants around the area. I can look at restaurants on campus. I then have to take a look at how much money I have in my wallet to find out which ones I can afford, because going over to the Wellington would be very nice, but it's not always affordable. It might be something like Chick-fil-A. It might be hitting one of the candy machines and getting a pack of crackers or something like that. Again, I have no clue how much money's in my wallet, so I need to take a look at that for what I'm going to do for lunch. That's going to be part of evaluating alternatives. What is the best one? If you've already taken decision science, you learn that you want to take a look at the optimum solution. And that's what decision making is all about, finding that optimum solution. So what would the best alternative be? Implementing. After you select the best alternative, implementing it. And most people say this is where decision making stops, but I disagree. After you implement, you need to take a look and evaluate the decision. Was it a good decision? If you're taking a look at location, if you're taking a look at pricing, you might need to lower your price, raise your price to make it fit better into what you need and what you want. When we work with decision making, we often use models. They're an abstract representation of a real-world process. When we take a look at models, we are taking a look at different types. One type is a schematic. It's a drawing. And you can have a room plan drawn out. Where you want your offices to be can be drawn out schematically. It can be a physical representation, more like building a small model, a little dollhouse of the office to know where you're going to put machinery, where you're going to put out the different offices, etc. Or it can be a mathematical representation. And in this class, we're going to be taking a look mostly at mathematical models. When we take a look first, we're going to look at a statistical decision theory, a model of rational selection from alternative courses of actions. Now, this becomes very important because we're going to be using these terms later. So let's start looking at these basic elements and figuring out what they are, what they mean, so we can use them in our later problems. Our basic elements start with alternative acts. Alternative acts are often listed as A. The different acts that can happen. This is what we will be doing. Events or states of nature that must be mutually exclusive and collectively exhausted. These are often listed as E. The different events are things that are out there that might take place and we need to know what it might be. We have no control over the events. The payoff or loss is taking a look at the consequences. What happens if a certain event takes place and we have chosen this alternative. What's the consequence? It's either a payoff or a loss. Criterion of measure constitutes the objectives being sought. How are we measuring this? And the environment representing the extent of knowledge about the state that will occur. How much information do we have? How much information do we know about what might actually happen? And that takes a look at what's considered certainty or risk. How much risk are we taking with our decision environment? Degree of certainty about the state of nature that may occur. With certainty, we know what will happen. We are 100% positive that something is going to take place, and we know that it's going to happen. With risk, we have a probability. It's a 50-50 shot that this will happen or this will happen. It's 33% chance that this will happen, 33% chance that this will happen, 33% chance that this will happen. That's dealing with risk. Uncertainty, we have no clue. We don't know what those statistical values are. We don't know what the likelihood is that something is going to happen. So we have to work towards what's called a maxi-max, maximizing our potential, maximizing our profit, or a maxi-min, which is maximizing how little we will lose. We want to minimize what's going to happen, and we want to take it to the most minimum point possible with that. So we're going to take a look at expected monetary values, and we'll come back to this definition in just a little bit, because once we work a problem, you'll understand it better. But it's found by summing for every state that can occur the products obtained when the probability that the state will occur is multiplied by the amount that is expected to be received if the act is taken and that state occurs. Now, it sounds like a lot of gobbledygook right now, but we're going to work with this in just a minute, and we're going to take a look at what it is that we need, that we'll be using to work with EMV, or expected monetary value. So we're going to use a decision matrix to do this, and it uses A, our strategies or alternative acts. We've already stated those. E, our states of nature or the events that might take place. And C, the payoff or loss, which are our consequences, given a certain state takes place and we decide on a certain act. So if we take a look at our problem, the Flying Goose Ski Lodge is gearing up for the midwinter school vacation week, which is traditionally one of the busiest and most profitable weeks of the ski season. The lodge's 4 rooms go for $80 per night, which is one of the least expensive lodges in the area. The lodge requires that guests cancel 48 hours prior to the reservation date in order to receive a refund. However, it is often still difficult to fill these rooms at the last minute. Thus, Flying Goose sometimes overbooks. But if the lodge is filled when the overbooked guests show up, the Flying Goose must find accommodation at other inns or hotels for those guests at their own expense, at a cost of $140 per room or more. The probabilities of no-shows are shown in the decision matrix on the next slide. How many rooms should the Flying Goose overbook? We're going to start this problem with some assumptions. The first assumption is that Flying Goose is booking all the rooms, and that people are not just no-shows, they're calling and canceling. So we're not collecting that money. They've actually canceled. So if we take a look at this problem, we've set up a decision matrix on whether or not we should overbook. That's what we're taking a look at. That's our objective, is to figure out, should we overbook or not? So if we take a look at our A's, our strategies, which is going down this way, we take a look at overbooking 0 rooms, 1 room, 2 room, or 3 rooms. The states of nature, something that we can't control, are our E's, which are going across, which could be 0, 1, 2, or 3 cancellations. The probability of having 0 cancellations is 0.5 or 50%. 1 cancellation is 0.25 or 25%, 0.15 for 2 cancellations or 15%, and a 10% or 0.10 for 3 cancellations. Now, in this matrix, we're going to be using numbers. We're going to put into this slide numbers that help us. And I want to take a look at the easy ones first. Let's do those, and then we can figure out what the harder ones are. And it's what is going to be our payoff or loss. And we're actually taking a look at a maxi-min. We want to minimize our loss here. So everything is going to be a negative. We're not going to be making any money, but how much money will we lose if these states of nature happen and we do a certain act? What act should we choose? We're going to assume that if all the rooms are booked, we're going to have a zero balance. That's what we're looking for. Instead of trying to figure out how many rooms we have, the number, we're using much smaller numbers, saying we want to book every single room, and we're looking just at a loss statement here. So we know information that our rooms are $80 a night. But if we overbook, it's $140 that we have to spend putting someone else up elsewhere, at least $140. So we know if we overbook 0 rooms and there's 0 cancellations, every single room is going to be booked and we're not losing any money. If we overbook 1 room and we have 1 cancellation, we can take that person who we overbooked and put him into the room that canceled. So again, all 40 rooms are going to be filled and we have no empty rooms and no having to put people else up where, no overbookings. If we overbook 2 rooms and there's 2 cancellations, each one of those overbookings can go into those canceled rooms. And again, we're taking a look at having all of our rooms filled. We're not losing any money and we don't have to house anybody elsewhere. The same thing with overbooking 3 rooms and having 3 cancellations. Each one of those overbooked rooms can go into a canceled room, and we again have that zeroing out. We're not losing any money. But what happens if we don't overbook any rooms and we have 1 cancellation? That means we have an empty room. An empty room means we're out money, and we're out $80. If we overbook 0 rooms and we have 2 cancellations, that's $80 for each room with 2 empty rooms. So we're out $160. If we overbook 0 rooms and we have 3 cancellations, that ends up with us having 3 empty rooms. They cancel, we're out this money. So 3 times 80 is $240. Let's look at overbooking 1 room. If we overbook 1 room and we have 0 cancellations, we have no place to put that person we overbooked. We have to find them another room at a minimum of $140. So we're out at least $140. If we overbook 1 room and we have 2 cancellations, that means we can take one of our overbookings and put them in 1 room, but we still have a room empty. So we're out $80. If we overbook 1 room and have 3 cancellations, we have that 1 overbooking we can put into one of our cancellations, but 2 rooms are still sitting empty. So we're out $160 for the night. If we overbook 2 rooms, that's 2 people and we have 0 cancellations. If we overbook 2 rooms and have 0 cancellations, we have to put 2 people up elsewhere at a minimum of $140 a night. So 140 times 2 would mean we're out $280. If we overbook 2 rooms and have 1 cancellation, one of our overbookings can go into that empty room, but we still have to find housing for 1 other person. So we're out a minimum of $140. If we overbook 2 rooms and have 3 cancellations, both of those overbookings can go into rooms, but we have that empty room again. So we're out $80 for that empty room. Looking at overbooking 3 rooms, if we overbook 3 rooms and have 0 cancellations, that's 3 different rooms that we have to get from other hotels at our cost at a minimum of $140 a night. So 140 times 3, we would be out $420. If we overbook 3 rooms and have 1 cancellation, we can take that 1 person, take one of those overbookings, put them in that cancel room, but now there's 2 other bookings that we have to find other rooms for at other hotels. So we're out a minimum of $280. Using this, we have overbook 3 rooms and have 2 cancellations. 2 of our overbookings can go in those 2 empty rooms, but we still have to take someone to another hotel and pay for that room. So we're out $140. Using this information, we are going to take a look. What strategy should we use? Overbook 0, 1, 2, or 3 rooms. You can use this slide. I have the information written on another piece of paper for me to use. I'm going to show you now how to do the formulas, how to do those mathematical models to figure out what we should do. So I have my scrap side here, my work paper, and I want to start with looking at overbooking 0 rooms. If we overbook 0 rooms, I want to take, and let's go back to that formula, I want to find the sum of every state that can occur, the products obtained when the probability that the state will occur is multiplied by the amount that is expected to be received if the act is taken and that state actually occurs. So I want to take a look at the probability that an event will take place and the outcome that is expected for that. So looking at that, I want to take my probability, and what we are looking at is this chart right here. I'm taking the 0.5 times here plus the 0.25 times here plus the 0.15 times here plus 0.10 times here to get my sum of what the expected monetary value will be. I'll then go down and work with overbooking 1 room on each one of these. So taking a look at this, we are overbooking 0 rooms. The probability of having 0 cancellations is 0.5, and our expected monetary outcome for having that is not being up anything and not being down anything. So it's multiplying it times 0. Overbooking 0 rooms with having 1 cancellation, the probability is 0.25, and our outcome for here is being out, that should be a negative, $80. If there are 2 cancellations, it's 15%, 0.15, and we're out $160. And heaven forbid there's 3 cancellations, which is a 10% probability, we would be out $240. So if we take a look at overbooking 0 rooms and we do the math on this, 0.5 times 0 is 0. 0.25 times a negative 80 is a negative 20. 0.15 times a negative 60 is a negative 24. And 0.10 times a negative 240 is a negative 24. So if I overbook 0 rooms, my expected monetary value for overbooking 0 rooms would be 0 minus 20 minus 24 minus 24, which is a negative 68. I would be out $68. If I overbook 1, I want to find the expected monetary for overbooking 1 room. Again, I'm using my 0.5 probability for having 0 cancellations, and I would be out that $140. The 0.25 for having 1 cancellation, I wouldn't be out anything. 0.15 probability for having 2 cancellations, I would be out $80. The 10% probability, 0.10, of having 3 cancellations, I would be out $160. So if I do the math here, it would be negative 70 plus 0 plus 0.15 times negative 80 is a negative 12 plus negative 16. And if to find this expected monetary value for overbooking 1 rooms, add all of those up, and it'd be a negative $98. To find the expected monetary value for overbooking 2 rooms, again, we're using the same probabilities. Our probabilities do not change. So 0.5 or 50% probability of overbooking 2 rooms with 0 cancellations is a negative 280. plus the 0.25 of having one cancellation, and we'd be out $140. That's a 140. 15% or 0.15 probability of having two cancellations, we're not out any money. And a 10% probability or 0.10 of having three cancellations, we would be out $80. If we do the math on this, we would have a negative 140 plus a negative 35 plus 0 plus a negative 8, and that is going to give us a negative $183 is our expected monetary value for overbooking 2 rooms. If we take a look at our expected monetary value for overbooking 3 rooms, again, using the same probability of 0.5 for 0 cancellations, we'd be out $420. 0.25 probability for overbooking 1 room, we would be out $280 plus 0.15 probability of 2 cancellations, we would be out $140, and 10% or 0.10 probability of having 3 cancellations, and we would break even there. Doing the math here, we're going to have a negative 210 plus a negative 70 plus a negative 21 plus 0. So overbooking 3 rooms would give us a negative $301. So what does all this mean? If our expected monetary value for overbooking 0 rooms was a negative $68, our expected monetary value for overbooking 1 room was a negative $98. Our expected monetary value of overbooking 2 rooms was a negative $183, and then our expected monetary value of overbooking 3 rooms was $301. Negative $301. What should we do? What would be the best option for us? What should we decide? What should be our action? Well, we lose the least amount of money by overbooking 0 rooms. So I would suggest not to overbook any rooms. Now, this is a very simplified with this. You can redo the problem with other assumptions that they didn't call in and cancel. They were just no shows. So you could actually charge them. And how much would you make if you had 40 rooms and 0 cancellations and 0 overbookings, or if you had, the no-shows, which is not a true cancellation, and you had 1 no-show, which means you can double charge for that room. You're charging the people, but then you can fill the room again. So you can take a look at using different assumptions to get different things, but you have to get those assumptions down on paper. But looking at this, our expected monetary value, we found it by summing up the probability times the outcome of each thing given what our course of action would be. So what would the event, and what's the probability of the event, and what would the outcome be? What would our consequence, the payoff or loss, be based on our course of action? That's what expected monetary value looks at. And again, here, and you really need to know how to explain your answer. Getting a number is only half the problem. Explaining what that number means is just as important or more important. Otherwise, that number's useless to you. So this negative 68 is the best option we have, overbooking 0 rooms, to get the most out of our money. And that takes a look at our decision-making chapter on here. We're going to go on next to take a look at product quality development in just a few moments.